Welcome back to the channel. Today we are going to dive deep into mini patch gradient descent and implement it from scratch in Python. So if you are ready to learn how this optimization algorithm works and how to code it, make sure to stick around. Before we jump into mini patch gradient descent, let's quickly review what gradient descent is. I've explained this in the previous video. So in the simple term, gradient descent is an optimization algorithm used to minimize the cost or loss function of machine learning models, particularly in the linear regression or neural networks. Right? As we train a model, the goal is to find the best parameters, like in the linear regression, the slope and the y-intercept, usually represented by the weights that we minimize the cost function. So gradient descent help us to do this by iteratively updating these weights in the direction of the steepest decrease of the cost function. So we calculate a gradient, the partial derivative of the loss with respect to the parameter and update the weights accordingly. Here you can see how the gradient descent progress toward the minimum of the cost function with each step, right? Adjusting the weight to reduce the error. So now in the traditional gradient descent, we compute the gradient using the entire data set for each update, which can be slowed and computationally expensive. On the other hand, the stochastic gradient descent (SGD), which I will explain in the next video, updates weights using just one data point at a time, which just speed things up but introduce a lot of noise in the updates. Now, mini patch gradient descent strike a balance between these two. So instead of using the full data set or a single data point, we divide the data set into smaller batches and compute the gradient based on these mini batches. So this gives the advantage of both worlds, the faster convergence and the reduced noise in the gradient update. Let us now break down how mini gradient descent works. Here are the basic steps, right? We initialize the weight randomly, set the learning rates, shuffle the training data, and for each mini batch, we compute the gradient of a loss with respect to the weight of the mini batch. Update the weight based on the gradient and the learning rate. And we'll repeat this until convergence or a specific number of epochs. At each iteration, the algorithm will shuffle the training data, breaking into mini batches, right? This mini batches, and then update the model weight using the average gradient for that mini batch. So this continue until the algorithm converges to the optimal set of weight or we reach the predefined number of the iteration. All right, now let's jump into the implementation. We'll write this in the Python, but walk you through the code step by step. So we'll start importing the NumPy for numerical operation and matplotlib for visualization. So this will help us handle arrays and the plot the loss function. For this demonstration, we'll generate a synthetic data set for a linear regression where y equals to 4 plus 3x. Y equals to 4 plus 3x. Let me generate this. Now we define a mean square error, the loss function, which measures the difference between the predicted and the actual values. So it is a common loss function for regression tasks. Let me run this cell. Now here is our mini batch gradient descent algorithm. So in this function, we shuffle the data set, split into the mini batches, right? And perform the gradient descent for each mini batch. The gradient are computed for each batch and the weight. So here I'm just computing the gradient for each batch and weight are updated. So here weights are updated using those gradients. And after each iteration, we store the loss to track the progress. So all the losses will be stored in the losses list here. So here we'll call, let me just run this. And now here we call the mini batch gradient descent function, passing the data, the batch size, the learning rate, and the number of epochs, the iteration. It will return the optimized weight, the bias, along with the loss history. So let me run this. And now let's plot the loss curve. So to visualize the training setup, we plot the loss curve to see how the model is converging over the time. So this will be very steep uh, decrease. As you can see, the loss was first 10 and then it is reduced to almost 0.48. Great. So we have now implemented the mini batch gradient descent for linear regression. As you can see, this approach helps speed up the training process while keeping the update stable. You can apply this technique to more complex machine learning models like neural network as well. So I hope you enjoyed this tutorial. If you did, just make sure to like and subscribe.